Now in this example, we need the current through the 2 ohm resistor. We're not told how to interpret that current direction, so we get to choose that arbitrarily, but we have to make a choice and we have to let everyone know what that choice is. I'm going to arbitrarily assume that current through this resistor is going to go in this direction. That means that according to Ohm's law, if I'm going to use Ohm's law, the voltage here, V2, has to have this polarity. Now if I can find V2, I can determine I2 from Ohm's law. Let's do KVL around this loop. So, starting down here, I see a negative terminal first on the 3-volt source, I see a positive terminal first on V2, and I see a positive terminal first on the 5-volt source. So V2 is equal to negative 2 volts, and I2, by Ohm's law, is going to be V2 over 2 ohms, which is equal to negative 1 amp. So I2 is negative 1 amp in that direction, which is a perfectly legitimate answer. But I can also switch the current direction arbitrarily if I want to. Positive direction is whatever I decide it to be. So let me do the problem over again with a different current direction. I'm going to claim that the current is going in that direction. I'll call this I sub x rather arbitrarily. If this is I sub x, positive current has to enter the positive voltage terminal if I want to use Ohm's law. So this is V sub x. Now if I do KVL again, I still get my minus 3 volts. I see the negative terminal first on V sub x, so I'll subtract that, and then plus 5 volts, the same as before. Now V sub x is equal to positive 2 volts. So all I've changed here is the sign, which makes sense because all I changed was switching my polarity. So therefore, I sub x by Ohm's law is 2 volts over 2 ohms, which is now plus 1 amp. So this is also a legitimate solution. It all depends on how you decide to define your positive current direction.